Stephen, when are we doing Declarative Amsterdam next year?
So unfortunately, this year couldn't happen on a Thursday, Friday, as we'd hoped, because this room had been booked for every Friday of the whole year. So I got in early and booked it for next year. Next year is the 2nd and 3rd of November, which is a Thursday, Friday. So please do come back
Yeah. So now off to Stephen for his talk.
Good. So this talk is born of IXML. Does the mic work? All right. Yeah. All right. Okay. So this talk is born from IXML. The principal aim of IXML, and some people miss this, is the extraction of structured abstractions out of representations. And those abstractions are the real important bit, that we get it, we get those things, and we don't care really what happens to it after that. We want those abstractions. Now, the main use at the moment is to serialize those into XML once you have that abstraction, but there are many other things you can do with it. For instance, my implementation, when it parses IXML, it serializes that into memory in the form expected of the early parser. And XML processors could do the same. They could just serialize it into memory, for instance, as an XDM. And there are lots more things that you could do with those abstractions. Now, yeah, what are abstractions? You may have seen this slide before. For instance, numbers are abstractions. You can't point to the number 3. You can talk about 3 bicycles or 3 sheep or 3 self-referential examples. And 3 is what those things, those bicycles, sheep, and examples have in common with each other. We can represent a number in different ways, 3, or as Roman numerals, or as binary, or as Chinese, or and so on and so on. You can concretize them or embody them as a length or a weight or a speed or a temperature, but in the end, that's all the same 3. The concept remains the same thing. Now, data is an abstraction as well. And the problem is that because we always have to deal with representations, we tend to mix up the representations and the abstractions in our head. But in the end, those representations are of the same abstraction. There's no essential difference between the JSON for a temperature scale Celsius value 21 or equivalent XML in 2 different serializations, or indeed just saying temperature 21 degrees Celsius. The underlying abstractions remain the same. However, what I want to talk about is about the external representation of those abstractions, and in particular in XML, which is currently the best available standardized notation available, generalized for generalized representations of abstractions. To represent abstractions, we need notations, and notations need to be designed. So XML was designed, of course. I wasn't involved with the design of XML. I am aware of at least 3 people in the audience at this moment who were there designing XML. I was just watching from the sidelines. HTML had become so successful that suddenly a lot of attention was being paid to SGML. The first version of HTML had sort of used SGML, and later versions, I think maybe from version 4, completely used SGML. But SGML is a complex language. I don't know if it's true, but I've been told that it's never been completely implemented. Did somebody say yes? There's one. Okay. All right. All right. But anyway, it was decided at that stage to simplify SGML to produce a subset, a pure subset, and call it XML. Now, I was watching on the sidelines because I'd been tasked with leading the group who were required to produce the XML representation of HTML. And so that design was going to be very important for us because we were required to use it and we had to be able to represent the things that we wanted to represent. I would say the designers did a good job. It's hard when redesigning something to avoid adding new stuff, but they really did produce a good design. However, I had come at that point from designing a project, working here, which you could call an environment, which we called views. It was, and actually still is, a system. I mean, still is in an abstract sense. It doesn't run anywhere, but it had lots of interesting properties. It had hypertext, it had style sheets, it had structured graphics. You can see these on the screen. It had client-side scripting, and it had an extensible data representation language. The interesting thing about the data language is that it had no standard external representation. You use the style sheets to display the data in any way that you wanted. In other words, we started with the abstractions, the design of the data model, and the representations followed. So what you're looking at, this is unfortunately the only screen dump I have of the system running. As you can see, it's in 1993. And these are just 4 different views of the same object, essentially. So we've got the system time in seconds, which is being displayed in a very primitive form as a number of long integers. And there you've got it displayed as a digital form of date and time. And here you've got a clock representing the same object. And these are all changing every second. That as the system time changed every second, then everything got updated automatically. So it was a very nice system to use. It ran on surprisingly low demanding hardware. It ran on the Atari ST, for instance. But what we designed was the data language, and we didn't care about how it was represented. That was up to what you wanted to do with the abstractions, as it was. So coming from that project, I did know about the requirements for a data representation. And so as I watched the development of XML, I used to ask myself, I wonder why they did that. And I just assumed that, they knew better than me, but I couldn't work out the reasons. It was only years later that I came to this quote from Tim Bray, who was one of the people who designed XML. And he said, the people who invented XML were a bunch of publishing technology geeks, and we really thought we were doing the smart document format for the future. Little did we know that it was going to be used for syndicated news feeds and purchase orders. And when I read that, a light went on. Oh, well, that explains it all. Now I understand why they made the decisions they did. Because, of course, I wasn't interested in a smart publishing format. I was interested in something for representing abstractions in general. Now, since we've had XML, there have been lots and lots of proposals for redesigns or alternatives. And quoting Tim Bray again himself, he says, just drop the doc type. Immense numbers of problems vanish. Mind you, the MathML crowd will come over to your house and strangle your kittens. But in reality, in the whole world, they're the only ones who care. If I were XML dictator, I'd drop it in a microsecond. So that was an interesting design quote there. That quote itself came in a comment to a proposal called XML5 from one of the people from the HTML5 group who wanted to redesign XML. Apparently, the only thing he really wanted to change was its error recovery, improve its error recovery. I'm going to talk about error recovery more in a minute. Another proposal comes from James Clark of Micro XML, as smaller and dramatically simpler, and oddly enough, also to allow error recovery. Then there's FTAN-ML. The slides are online. These are all links. So if you're interested in knowing more about these things, you can just click and find out of them. Michael Kay, his exercise with students at designing something better than XML, which was good at data and structure, data as well as structured documents, concise, human readable, with a data model applicable to programming languages, and dealing with the white space problem, which I'll talk about later as well. There have been several proposals for binary XMLs just to make it more compact. And of course, XML 1.1 itself was a redesign in a way. It changed the definitions of names, which actually got grandfathered into 1.0. And it also changed the allowable characters in the data model, which I'll mention later as well. So let me just mention error recovery and why I think that it's not something that we should worry about. Information representation is a sort of contract. You want to send somebody data, and you've got to do that in some representation or another. And you want the receiver to receive exactly what you sent. It's a sort of contract. If the receiver silently tries to guess what you meant, that contract has been broken. There's no guarantee now that you're talking about the same thing, because the other person has sort of made up something about what they think that you meant. Now, error recovery is an example of the robustness principle, which I'll talk about a bit more generality, also known as Postel's law, which says, be conservative in what you produce, be liberal in what you accept from others. The robustness principle was proposed in order to improve interoperability between programs. And somebody once expressed it as, you'll have to interoperate with the implementations of others with lower standards. Do you really want to deal with those fools? Better to silently fix up their mistakes and move on. So the robustness principle can be useful, but it's not a law, and it's not like the greatest thing on earth that everybody has to follow. You should be careful where you apply it. And I'm going to give you a couple of examples where it's been wrongly applied. In general, it's not been applied to programming languages in general. Just imagine if the compiler tried to guess what you really meant when it came across an error. That's bound to cause problems. But it was actually done in PL1, and it was terrible because the only way you could find mistakes was debugging, running tests. And as Dijkstra famously observed, programming testing can only be used to show the presence of bugs, but never to show their absence. Snowball had no, okay, thank you. That's another good example. I've got one more example after this as well. It's much better for us if the compiler says you've done something wrong, fix this before I do anything with it, because you only have to do that once. You don't have to keep searching for mistakes. Studies have shown that 90% of the cost of software comes from debugging. So reducing the need for debugging is of the essence. Now, actually, the robustness principle has also been applied to JavaScript. Did you know that plus, open bracket, close bracket, blah, 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 evaluates the string 10? It really does. And if you click on that link, you will get an explanation of why it evaluates to the string 10. I mean, it's not sensible, but it does it. This makes JavaScript very hard to debug because it silently accepts certain classes of errors, doesn't tell you about them, and then later on in the run of the program, suddenly things start going wrong, and trying to trace that back to where the error really was is very hard. Let me give you an example that I spent a whole afternoon debugging this damned program, not written by me, written by somebody else, but it wasn't doing it properly. It was JavaScript calculating the number of seconds from the number of hours and minutes. So the code in essence was seconds equals 60 times the hours times 60 plus minutes. So hours times 60, that gives you the number of minutes. You add the number of extra minutes, and then you multiply that all by 60 to get the number of seconds. Well, I happen to know that hours was 1 and minutes was 0. So the answer should have been 3,600. But the answer was coming out at 36,000. Exactly. Hours and minutes were both strings, but they were set far away from this bit of code, so it wasn't immediately obvious. So hours times 60 converted hours to a number and multiplied it by 60, giving 60. But then the 60 was converted to a string and concatenated with the 0 of minutes, giving 600. That was then converted to a number and multiplied by 60, giving 36,000. Now, as I said, it cost me a whole afternoon to discover how on earth this was going wrong. But it's an example of the programming language thinking it knows better than you and just doing stuff to be helpful, but it's not helpful at all. So this is the reason why I also believe it's bad to have error correction in data notations. Now, in our view system that I was talking about, we never had the need for error correction. And the basis is, well, how do programmers work? They write their program, they compile it. If you get errors, then you fix it, and you keep doing that process until it compiles, and then you run it. And that was the same with documents that didn't match their style sheet. It displayed as much as it could, and then a big red blob saying something's gone wrong here, and you would go in and you'd fix it until it worked properly. That's how people work with HTML as well. They do stuff until it looks all right and then send it off, but it only looks all right because it's been fixed up, and you don't know for sure whether it really is right, but it's still being fixed up. What I think is a widely overlooked aspect of the design of notations in general is usability. That usability is normally thought about as an interactive property of programs, but there's much more to it. The generally accepted definition of usability is that you want to reduce the time needed to achieve a task. You want to reduce the number of errors while doing it, and you want to try and make it as fun as possible while you're doing it. Some definitions add learnability, but I personally think that learnability is a separate issue. So as an example of usability, Roman numerals, that's the number 2022, and so this year, in other words, this is just fine for representing numbers. It's sort of okay for addition. It's not too hard to do addition of these forms, but it's absolutely terrible for multiplication, and it's almost impossible for division. Actually, and until the introduction of the style of numbers we use now, Indo-Arabic numerals, multiplication was a university subject. But after the introduction of Indo-Arabic numerals, it was much easier to perform these operations. You made less errors. It was much simpler and therefore more pleasurable. And nowadays, even school children can do multiplication and division, whereas in the Middle Ages, you had to go to university to learn how to do it. Another example of the lack of usability that I like to give is the two-letter abbreviations for state names in the United States in postal addresses. For example, NE, is that Nevada or Nebraska? Well, it's Nebraska as it happens, but if they'd chosen NB, I wouldn't have had to ask the question. It would have been obvious. Oh, in Canada. Yeah, okay. Mutually exclusive. So you mean that Canada is part of the deal? Yes. All right, I will rerun my program. Okay, that's good. That's a good bit of information. I shall rerun my program. I only ran it for the United States, it's true. But MI, it could be Mississippi, Missouri, Michigan, Minnesota. It's Michigan, but if they'd chosen MG, it would have been a better choice. This solves the problems for reading the codes, but you still need to know how to get from the state name to its abbreviation. And at this moment, in both directions, you have to memorize them. But so just for the United States, I wrote a program to discover if I could find a pattern that was easy to remember. And in fact, I could. If two-word names, you use the first letter of each name, like New Brunswick then. And otherwise, you use the first and fourth letter of the state name, unless there's a repeated letter in those first four, and then use the first and fifth. That gives you a unique set of letters. So if you see the state name, you can generate the code. And if you see the code, you can work out which state it was. So that's an example of usability, which they haven't applied. But if they put a little bit more thought into it, it would have made those abbreviations much easier to use. By the way, there's a great video of a man pretending to be a member of the committee designing those abbreviations. You should definitely look it up. In fact, I'll put it into the slides later because it's very, very funny. Right. So usability. Yeah. So usability in XML. A couple of examples where I think they did the right thing is, for instance, that attribute values should always be quoted. HTML doesn't have this as a requirement. But the problem is that you have to know and memorize the rules where you can leave them off. And I know lots of people get it wrong. And of course, HTML corrects. And so it tries to guess where to put the quotes around it, as it were. And I've had to deal with people's HTML where they did it wrong. And it's caused me endless problems. Yeah, so HTML fixes up, and you can't be sure how it's fixed it up. That in itself causes other errors and slows you down trying to find the source of the error. Even worse is that CSS and JavaScript, which can be embedded in HTML, have different rules for quoted items where you can leave the quotes off. And so you've got to sort of remember 3 rules at the same time. So I think that this rule is a good one in XML. Another example is the requirement that the closing tag and the start tag and the close tag be the same. It helps error messages be much more locatable where the error is, because if you've just got generic closing brackets, then at the end of a huge load of closing, it says mismatched, and then you have to, it's much more work to find out where the mismatch is. In this method, you find the mismatch much earlier. Okay, so what I now want to talk about is how XML has got in the way of properly representing abstractions, the places where I've tripped up or had problems with XML because of its design. And I want to talk about how that could possibly be fixed. And one of my aims in describing these things is that existing XML documents should remain valid with exactly the same meaning. So I'm looking at a way of redesigning XML so that it can better represent abstractions without changing the past. Now, when we were designing a view system, one of our desiderata for that, for the data language that we were designing, was that there should be a simple algebra of documents. For instance, if you had 2 documents, A and B, then A plus B, the concatenation, was also a document. Furthermore, there was also a 0 document, so that A plus 0 was the same as 0 plus A, which was the same as A. Also, we wanted composability so that if you've got one document, you could compose it with in other documents, embed it in others. Now, text, for instance, has all of these properties. You've got 2 text files, you can stick them together, you can put them inside. There's an empty file that has the zero property. And XML really has none of these. You have to do special stuff with the documents in order to be able to do these actions. And I'll talk about that a bit more shortly. Now, characters. Now, one of the problems, and presumably because they were designing a future print format, is that there are certain characters banned from XML. And from a print documents perspective, this is fine. But from a content perspective, for representing data, for representing abstractions, it's not. And it means that there are documents that you would like to represent that you can't represent directly in XML. For instance, if I want to make a table of key bindings, just to name something, I'm forced to encode those banned characters in a different way in order to include them in my content. And that means that then I have to process them to get them in, and I have to process them to get them out again. So I have to do something like hat A or something when I actually just want to put the character 1 at that point. Now, one solution, which I believe is also used in XML 1.1, is to allow character entities for any character. You're not allowed the literal character in the representation, but you are allowed to represent it using a character entity. And I think this is a good solution. I recognize that the zero character still creates a problem here. I'm not trying to solve that one this discussion, but at least this is a good solution for getting most characters into an XML document. Attributes. So what are actually attributes for? And preparing this talk, I went searching across the web looking for an official reasoning behind attributes and what they're actually meant to represent. And I couldn't find any conclusive answer to this question. Are they intended as metadata about an element, for instance? Not clear. They seem to be a special case of element children, but they have special restrictions. First, the content, of course, is unstructured. It's just a string. Secondly, compared with elements, attributes are unordered. So you can't say anything about the order of attributes, even if you put them in a particular way on an element. And the third one is, whereas you can have several elements called class within a paragraph, you can't have several attributes called class on a paragraph, because you can only have one attribute of a given name on any element. Quite honestly, those last two points I find difficult to understand. Even worse, that last one is hard to understand, because what that means is that people start inventing languages where attributes have a sort of hidden internal structure, so as class, because you're not allowed to have several classes on an element. I don't know, I don't understand why not, but it's unfortunate, really. White space is a long recurring problem with XML, and some languages have tried to fix this. The main problem being, it's hard to identify whether the white space you've got is real content or just been added for readability purposes of the XML. The XML spell does allow you to say something about the white space content of elements, and I have to say that the HTML working group broke their heads over this one, because it only has two values. One is preserve and the other is default. And those don't seem to be exactly exclusive values. We were lucky that we only wanted preserve, because CSS provides the values for how spaces should be treated when displaying. So we had control over that. In other words, preserve and default for us were exactly the same. We solved this in IXML by putting all content into attributes. So the question doesn't arise at all, because all the characters that we're interested in are in attributes. And so, in other words, all white space is just decoration. In XForms, on the other hand, we did want more control over what you can do with white space in elements. And in attributes, as it happens. And we can assign a white space property to a value. The use cases that we found we had, and so put into the language, are preserve, remove. So preserve is, for instance, program code. You want everything preserved there, or a poem, maybe. Remove, you want it all removed. For instance, a credit card number, you only want those digits. Trim, remove the white space at the beginning and the end. For instance, an email address. It's surprising how many errors you can get on the web still if you type your email address in and it gets inserted automatically by your phone for you, and with a space at the end. And then they say, this is an illegal email address. And you look at it and you think, no, it's fine. What's wrong with it? But what's wrong with it is that there's a space at the end and they're too lazy to strip spaces off. Collapse, removing multiple white space and replacing it with a single space. And then normalize, which is a combination of trim and collapse. For instance, somebody's name, you want to get rid of the stuff at the start and the end, and you want just a single space between their names. I would say these would be reasonable values for an XML space attribute as well, just because we have use cases for all these things, and I would have liked to have known what the discussion was, and I hope somebody will be able to help me out that produced preserve and default. My last point is rootedness. XML has this rule that a document must have a single root element. Now that, for me, that's like having a file store that only allows you a single directory at the top level. For instance, XPath lets you select a group of elements. So for instance, you say /HTML/body/star, which would give you all the top elements in an HTML document. I've left namespaces out there. That's a different argument. Now, in Xforms, I often have ref equals /star in order to get the root element, because I don't care what it's called, because it's only the elements underneath that I really care about. But what this shows me is that just like file source, XML already has a top level single root, namely /. And it doesn't really need to restrict it any further, that you could have several elements under that, and it would still be processable in a very reasonable way. For example, I wrote an XML server using REST protocol where every resource was an XML document. For instance, you put an XML document, and then that just got put in a file. I could get that obvious how that would work. Delete was also obvious, but when I came to post, it wasn't exactly obvious. What I wanted to do was append the incoming document at the end of another one. So for instance, if I was registering people for something, then every time they submitted, then I would just put another member element at the end. But this is irritatingly hard work to do right, to update that file. While actually there's no reason why this shouldn't be just a valid XML document where I just add, I compose it of many elements. And I can still say ref equals /star, and I get the set of top level elements. And I don't see why why that should be restricted, frankly. Similarly, this would mean that the empty document would then be a valid XML document. And that all of this together would give you the simple algebra that I was talking about earlier. If you still want single rooted documents, that's fine. You can still have them. But I don't really see why it should be restricted. So my conclusion, XML was designed as the smart document format for the future. And we are now using it outside of those design criteria. We shouldn't see the need for change as a criticism of the original design because it matched its original design criteria. It's just a recognition that the design closely enough matches what we now want to use it for, and that it can be adapted to match our new requirements. But I think that those new purposes really do need those changes. The advantages of what I'm suggesting here is that existing XML documents remain as XML documents with exactly the same meaning in the new definition, while allowing greater expressibility and flexibility for the representation of abstractions. Thank you. I was hoping you'd come up. Oh, good, good. Right.
Oh, excuse me. Okay. If you were to read XML space equals as XML white space only nodes equals, because the impact, the scope of XML space is only those text nodes that are comprised entirely of white space characters. And the reason you have preserve and default is that white space only text nodes show up in two places in XML documents. One is element content, where an element is only made up of element children. and the indentation between those is comprised entirely of white space. The other place it shows up, unfortunately, well, not unfortunately, but the other place it shows up is in a paragraph. If you have two elements that are next to each other, separated by white space, there is a white space only text node. So you can't distinguish from the white space only that's used for indentation or the white space that's only in there. So by saying white space equals XML space equals preserve, you're saying all white space only text nodes shall be preserved in the output as you have successfully used. When you say XML space equals default, then you look at the XML spec that says what happens with element content and what happens with mixed content. And element content, a processor is allowed by default to choose to preserve or throw away white space only text nodes that are used in element content. And that's why the string default is used, because it's then up to the XML processor and its behavior as to whether or not it's going to throw away white space only text nodes used in element content. So that's why there's only two values, why it doesn't apply to all text in the document, and why it came up in the first place is because of the distinction of handling element content. Okay. And yes, it is a bit misleading to say XML space if you think of XML colon white space only text nodes in element content equals. Now, the second one that I thought to write down, I think there were others, but I'll stop at two. The slash representing what you called the root node. Yep. Well, the root element. Those of us who are on the committee squirm when people call it the root element, because it's called the document element, because the root node is one level higher than the document element, because, and it could never represent the document element, because in XML from SGML, there are annotations that are allowed outside the document element, comments and PIs that could happen before the beginning of the document element and after the end of the document element. And if you have to address those, you have to be one level higher than the document element in order to be able to address those. And so the slash represents the root node whose first element child is the document element, because before and after the document element, there could be child PI nodes and child comment nodes of the root node. And I acknowledge that so many in the community call it the root element. And it's just that our skin crawls a bit because we hear that, but it's formally called the document element, which would not mean anything to anyone. So I certainly understand why people call it the root element, but that's not its proper name. I'll stop there. And if I think of anything more, Stephen, I'll pull you aside.
Any other comments or remarks? Yeah, over there.
Oh, I finally get to throw this thing.
Stephen. Stephen, did you, when you talked about concatenating documents, did you consider what should happen with the XML header?
Well, I mean, the XML header is a big problem, and it was a big problem for XForms as well, because I mean that's what I was talking about, embedding documents within documents. That made life very difficult for XForms, because we're embedding XML documents all the time, and you can't. There's a difference between embedding textually and embedding via a resource link. So I haven't addressed that problem, but I appreciate that it's a pain. Diederik, you want to say something? Oh, you're next. Okay, I'm sorry.
There is still time, so it's a nice discussion. If there are any others who want to chime in.
Anything on the
Ken, your points 3, 4, and 5.
On
You,
the chat, I mean, I'm surprised Norm has not said anything to agree. How about
Tom, we need
Charles
you.
Michael Spurberg McQueen? He hasn't said anything.
Okay.
I'll unplug my computer so you can start setting up. Who does? Oh. Well, you can read it out.
Wendell has a question saying,
Oh.
yes, Ken, but the rule that there can be only a single document element? Question mark.
Fumble. In-memory representations of node trees can certainly have more than one element child of a document element, but that can't be serialized as an XML document. It can be serialized as an XML entity, a system entity that can be included. But when you read an XML document, you only get the one document element as the one element child of the root node. If I've understood the question from Wendell correctly.
I guess.